Hello guys, so in this video we are going to see problems on Bayes theorem. Bayes theorem I have explained in the previous video. You can watch that video and then you can come to this video. We will see some kinds of Bayes theorem problems which are frequent in exams. Okay, so I'll be doing these three and I hope this will make your idea about Bayes theorem very clear. Okay, so let's start with the first question. So first I'll explain you the question and then we will start with solving. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, scooter spelling is wrong here, double O should be there, 4,000 car drivers and 6,000 truck drivers. Okay, the probability of the accidents are, probability of the accidents means scooter will meet an accident, the probability is this much, car will meet an accident, the probability is this much, and truck will meet an accident, the probability is this much. So one of the insured person meets an accident. Okay, so one of these person who brought the insurance from that company, he meets an accident. What is the probability that he is a scooter driver? Okay, what is the probability that we select a scooter driver? Okay, so here we have an insurance company which insured 2,000 scooter drivers, 4,000 car drivers and 6,000 truck drivers. Insurance company is giving insurance to them. Okay, and the insurance company knows that the probability that scooter will do an accident is 0.01. The probability that car driver will do an accident is 0.03, and a truck driver will do an accident is 0.15. That is the probabilities. Okay, so now one of the insured person meets an accident. So out of this people, one person meets an accident. So what is the probability that he is a scooter driver? Okay, so first focus on this. What is the probability that he is a scooter driver? So in this case, whenever you read a problem, see what is to find. So what is the probability that he is a scooter driver? Okay, so you need to find the probability of scooter driver. So let us define that. Let E1 be the event of choosing scooter driver. Okay, choosing scooter driver. So I have defined this event, but I have another car drivers also, truck drivers also. So I cannot neglect their probability because they have said one of the insured person meets an accident. So the accident may have come from this also, or it might have come from this. I don't know. It might have come from here. So let's make all of them events. So E2 be the event of choosing car driver, and E3 be the event of choosing truck driver. Okay, so whenever you read a problem, always see what you have to find and then according to that define your event. Okay, so now what is the probability that you choose a scooter driver? That you need to write here. Once you have defined these events, you have to find their probability. Check. There's 2,000 scooters. That means out of 2,000 you can pick one, right? And total how many are there? 2,000, 4,000 and 6,000. Total is 12,000. 12,000. Okay, so I can say this is 2 by 12, right? I can cancel, but I will not. So probability of second event, choosing a car. So how much is the probability of choosing a car? 4,000 by 12,000. So this is 4 by 12. And what is the probability of choosing a truck? That is 6,000 by 12,000. I'm not cancelling it because later I will have to take LCM, so that's 6 by 12. Okay, so this is the probability of our events. We are not finishing. Now see what they are given. One of the insured person meets an accident. Okay, one of the person meets an accident. Okay, so let's define that as A. Like in the formula, let A with the event that an insured person meets an accident. Okay, meets an accident. So what we need to find? Look here. They're asking one of the insured person meets an accident. What is the probability that he is a scooter driver? Scooter driver is this. Okay. See here we have not considered anything because there is a condition given. One of the insured person meets an accident, then he should be a scooter driver. Here these are only insured person. There is a probability of choosing a scooter driver. We don't know whether he has met accident or not. Okay, so here what I have to write here now, what we need to find? We need to find probability. Now what we need to find, you see here, probability of the scooter driver and that he meets an accident. Okay, so this is given to us already, that he meets an accident. Okay, so probability that it is a scooter driver, probability that it is a scooter driver and he meets an accident. This is what we need to find, and this is how we do probability of E1 into probability of A given E1. You know from the previous video, and below we have probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. E is accident happening. Okay. Okay. Now you can see that I have already found probability of. You can see that I have found probability of E1, probability of E2, and probability of E3. You can see here probability of E1, E1, E2, E3. But I need to find probability of A given E1. That means what is the probability that a person meets accident from scooter? Who's driving scooter, he meets an accident. This A given E2 is probability of car driving person meets an accident. Okay, and this is probability of truck driver meets an accident. Okay, so this we need to find probability of, mark this as 1. Okay, so probability of A given E1. What is the probability that a scooter driver meets an accident, which is already given to us here? You can see probability of the accidents are this, this, and this. So 0.01. 0.01, that is 1 by 100. Now probability of a car driver, we choose a car driver and then we see whether what is the probability he meets an accident. Okay, so let's see what is the probability. It is given as 0.03. So this is 0.03, that is 3 by 100. Okay, and then next we need to find probability of A given E3. Probability of A given E3. That means a truck driver meets an accident. So what is given? This is given 0.15. Truck driver meets an accident. So what it is? 0.15, that is 15 by 100. Now from one probability of a scooter driver meeting an accident. That is what is asked in the question. Okay, please listen to what I am saying very carefully, then only you will understand. So this will be probability of E1. What is the probability of E1? Is 2 by 12. So 2 by 12. Next, what do we have? Probability of A given E1. Probability of A given E1 is 1 by 100. 1 by 100. And then below you will write probability of 2 by same probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Okay, so all of them I have found. Okay, so after I do it, please do it yourself once. What is probability of E2? Probability of E2 is 4 by 12. 4 by 12 into probability of A given E2. A given E2 is 3 by 100. 3 by 1200 plus E3. Probability of E3 is 6 by 12. 6 by 12, and probability of A given E3, which I found here, that is 15 by 100. So this is how you will write. Then later you can solve it easily, because see, I did not cancel because of this. This is 2 by 1200. This is 2 by 1200 plus 4 3 is 12 by 1200. I am not cancelling because see, this 1200 and this 1200 after taking LCM will be cancelled. 15 6 is 90 by 1200. Okay, so this will be, if you take LCM, 1200 will be cancelled from numerator and numerator, so I'll be left with 2 by 102 104. So 2 by 104 will be your answer, which can be cancelled 1 by 52. So there is a probability of 1 by 52 that a scooter driver will meet an accident. Okay, there is a probability of 1 by 52 that the person who is meeting an accident is a scooter driver. Okay, so I hope this is clear. Let's go to the next question. Okay, now this question says, please learn to read the question very nicely. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false positive result of 0.5% of a healthy person tested. If 0.1% of the population actually has the disease, what is the probability that a person has the disease, given that his test results is positive? Now, first thing you need to know that there is a test, okay, which is 99% effective. That means if a person is having a disease, it will catch for 99% time. Okay, out of 100 times, 99 times it will catch. Okay, so that is 99%. Okay. However, the test also yields a false report. So for healthy person also it gives a false report. What is the percentage of that? 0.5%. Out of 100%, 0.5% chance is there that a healthy person will be detected sick. Okay, and 0.1% of the population has the disease. That means there is a population. This is the population. Okay, so out of that, this much has disease. They are sick. Okay, they are okay. Okay, so 0.1% are sick. 0.1% are sick, and how much? 99.9 are not sick. They are sick. What is the probability that the person has a disease? So what we need to find, focus on this. What is the probability that the person has the disease? So what is our event? What is our event? Event will be E1 has the disease. Okay, E2 does not have the disease. Okay, this is what we have. Then I will find my probability of E1 and probability of E2. Then I'll see what is given. Given that the test result is positive. Okay, so I will write my A and then I will solve. I hope this is clear this much. I think it should be very much clear. So let's define our event and then I will draw a diagram for you to see. Okay, so let E1 be the event. A person has the disease. And E2 be the event. A person does not have the disease. Okay, so now just don't start looking from the beginning. Okay, so in these type of questions, the real things will be given in the middle of the question. Okay, so they are saying person has the disease. Has the disease means what? In the population, how much people have the disease? So this is the total population. Okay, so here 0.1 will have the disease. They are having disease. So E1. This is E1. In this case, I will get E1. Even that person has a disease. And E2 that 99.9%. If these are not having, simple direct idea. These are having the disease, these are not having the disease. Okay, so now can I write the probability of E1? E1 probability is it's 0.1%. So whenever you see 0.1%, percent means divided by 100. So this is 0.1% means divided by 100. So I can write this as 1 by, I can write this as 1 by 1000. Probability of E2 is equals to 99.9%, means divided by 100. And how did I get 99.9? I subtracted this from 100. Okay, because we have 100%. So this is 999 by 1000. Okay, I hope this is clear. These are the people that have the disease, and 1 out of 1000 are having the disease, and 999 out of 1000 are not having the disease. I hope this is clear. Now let's define our A. What is our A? Given that the test result is positive. Okay, so A, the event that test result is positive. Okay, so what we need to find? What we need to find? Check here. What is the probability that the person has the disease? That means E1. Given that the test result is positive, then how do we write? Probability of E1 given that test result is positive. This is what we need to find. Okay, so we need to write it there. Okay, so to find probability of E1 given that test result is positive. Okay, the sick person is selected and he has his test is positive. It should be clear here. What is the probability that a person has a disease? Okay, so they are taking 1% from there and then they're checking whether he has the disease or not by doing the test. Okay, so they are asking what is the probability that person has the disease, and the result is also positive. So this is E1 is the event of having the disease, right? Here I have explained person has the disease. So E1 is the event that person has the disease, and A is the result is positive. So how do we write it? Probability of E1 into probability of A given E1 divided by all the events we have. Probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Okay, so this is 1. Mark it as 1. So I have this one, E1 and E2 I have, right? But I don't have probability of A given E1 I don't have, and probability of A from E2 I don't have. How do I read this? Probability that I take out a sick person and his test is positive. This is probability of I take out a healthy person and his test is positive. So what is given in the question? See, false result of 0.5% of the healthy person. So healthy person, which is the healthy person? This is our healthy person. So he will be tested positive. How much times? 0.5%. 0.5%. 0.5%, that means 0.5 out of 100. This is healthy person E2. Okay, so what is the probability that his test will become positive? So it is given to us. That is 5 by 1000. Okay, and what is the probability that a sick person is selected and his test is positive? It is 99%. You can see here 99% effective in detecting the certain disease. 99% times it will detect the disease. Okay, so that means what is the probability the test is positive for a sick person? It is 99 by 100. Okay, read the question nicely. You will find out. 99%. That means 99 by 100. This is 1000 here. Okay, this is 1000. Okay, so 99 by 100 times you will get the test positive for a sick person. Okay, now let's substitute from 1. Probability that a sick person is selected and his test is positive is, so see what is the probability of E1, what is the probability of E1 is 1 by 1000, is 1 by 1000, 1 by 1000 into, and probability of A given E1 is 99 by 100. And then what is the denominator? Probability of E1 into probability of A given E1. So probability of, same thing I will write here, 1 by 1000 into 99 by 100 plus, what is next? Probability of E2 into probability of A given E2. So probability of E2 is 999 by 1000. 999 by 1000 into probability of A given E2. That means 5 by 1000. 5 by 1000. Okay. So if you multiply, then you will get 99 by 1, 2, 3, 4, 5, and this is 99 by 1, 2, 3, 4, 5, plus this is 999 into 5. Okay, you can do the calculation. 1, 2, 3, 4, 5, 6. If you take LCM, 2, 3, 4, 5. Here if you take LCM, 1 by 6 zeros, 1, 2, 3, 4, 5, 6 zeros, and here you will have 990 plus 999 into 5 is 4995. Okay, so this from here I will cancel 5 zeros, from here I will cancel 5 zeros, and this 0 will go up and it will be 990. Okay, 990 by 5 and 9, 18 carry 1 and 18, 5985. Okay, so you can put the answer here. So that is how you will find your answer. Okay, let's do the last question. If you are finding it confusing, please rewind and watch it. Okay, now the last question. Now read the question very nicely, otherwise it will be difficult for you. A manufacturer has three machine operators A, B, and C. The first operator A produces 1% defective items, whereas the other two operators B and C produce 5% and 7% defective items respectively. A is on the job 50% of the time, B is on the job for 30% of the time, and C is on the job for 20% of the time. Okay, so the defective item is produced. What is the probability that it was produced by A? So I have a company. It has machine A, it has machine B, it has machine C. Now, for selecting A, suppose you go to, this is your company, and you go to the company and check. So 50% of the time you will see that you will get this A. 30% of the day you will get this. 20% of the day you will see this machine running. Okay, so these are the probability. So how many times? 50% they are giving. So I will write like this: 50 by 100. We take the whole day as 100, and in that 50 of that day, 50 parts of that day, if you divide the day into 100 parts, 50 parts of that day, you will see machine A doing what. 30 parts of the time you will see B machine working, and 20 parts of 100 you will see that C is working. Okay, this is given. Now this machine can make a defective and non-defective item. This machine also can make a defective and non-defective item. Okay, defective, non-defective, defective, non-defective. There is a chance this machine also can make a defective or non-defective item. Okay, so what is given? This produces 1% defective. Okay, let's not look into this, but what is given, let's write that. B produces 5% defective and C produces 7% defective. Okay. Okay, so this is not necessary that you will do how I do. Okay, you need to make a picture in your mind like this. What we need to find? You first write down, okay, and then you put the formula and then substitute the formula. Very easy idea, okay. But if you break it like this, it will be more clear to you. So a machine is working. Our company has three machines, this, and this. Okay, they produce defective and non-defective items. Defective and non-defective items. You can see like this, and their percentage of defective and non-defective items are given. Okay, so what is the probability that it was produced by A? So they are saying what is the probability that it was produced by A. So you got your event. You got your event. What is your event? So let's define the event. Here the question says what is the probability that it was produced by A? It was produced by A. That means we need to select A first, right? So let E1 be the event of selecting machine A. Machine A. E2 be the event of selecting machine B. E3 be the event of selecting machine C. Okay, machine C. So now what will I do? I will find the probability of E1. What is the probability that I select a machine? I select machine A. To select machine, I need to go to the company, right? So how many times it is working? 50% of the time it is working. So I will see the machine working 50% of the time. Okay, so that is my probability of getting machine 1. Then it is can be written as 5 by 10. What is the probability that I select machine 2? That is 30% of the time. So 30 by 100, that is 3 by 10. And probability of third machine is 20 by 100, that is 2 by 10. Okay, now what is given? A defective item is produced. Okay, so let's define that. A is event that item is defective. Item is defective. Okay, so what we need to find? What they are asking? A defective item is produced. What is the probability that it was produced from A? That means from E1. What is the probability? What is the probability that item is defective? Item produced is defective, but it is from machine 1, that is E1. Okay, so this is, how do we write? Probability of E1 into probability of A given E1. So how many machines are there? 3 machines are there. That means I need to write 3 of them. E1 probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. So this is 1. Okay, now I need to find my probability of item defective from my machine 1. What is the probability that machine 1 will produce defective item? What is the probability that defective item is produced from machine 2? You read it like this: probability that I choose a machine 1 and the item is defective. Probability that I choose machine 2 and item is defective. Probability that I choose machine 3 and item is defective. So it is given, I think, in the question. See, A produces 1% defective items. Okay, so that is 1 by 100. And B produces 5% and C produces 7%. Okay, B produces 5%, that means 5 by 100, and C produces 7%, 7 by 100. Okay, now from 1 we substitute in 1. From 1, probability that item is defective. Item is defective, but it is from machine 1. Okay, so that is, write down the values. First, probability of E1 into probability of A given E1. So probability of E1 is 5 by 10. 5 by 10 into probability of A given E1. Probability of A given E1 is 1 by 100. 1 by 100. Same thing I have to write here. 5 by 10 into 1 by 100 plus probability of E2 into probability of A given E2. Okay, probability of E2 is 3 by 10. 3 by 10 into probability of A given E2. You can see here 5 by 100. 100 plus probability of probability of E3. How much is probability of E3? 2 by 10. 2 by 10 into probability of A given E3, so 7 by 100. 7 by 100. Okay, so I'm not cancelling those because you can see that can be cancelled. So this is 5 by 1000. This is 5 by 1000 plus 15 by 1000 plus 14 by 1000. 1000 can be taken LCM and cancelled. So this is 5 by 20, 34, 34. So that should be your answer. Okay, 5 by 34 should be your answer. So this finishes your Bayes theorem. Okay, repeat this video, you will understand it nicely. Okay, so I will see you in another video. Thank you.